Hi, Assalamualaikum. My name is Muhammad Daniel and I'm from Group 15. This up here is my ID. In this video, I'm going to talk about chemical bonding. Before that, this is something that you need to remember and know. Okay, move on to the electron shell. Every atom has their own electron which is orbit in the nucleus. The first shell can only fill with 2 electrons before move to other shell, while the second shell can fill with 8 and so on. The octal rule. Partially filled electron shell are unstable, so atoms want to fill their electron shell completely. Sun shell can only hold 8 electrons. This phenomenon is known as the octal rule. Atoms fulfill the octal rule by bonding with other atoms. Okay, so if atom bonding with other atoms, then it will be called chemical bonding. They will fill their electron shell and gain stability. Some elements have a perfect electron that is needed by other. This makes other electrons more compatible for bonding with. Here the interesting part. There are two chemical bonding, ionic bond and covalent bond. As you can see, the ionic bond takes place when one atom steals the electron of another atom, resulting in stability for both atoms. We are going to talk about a transfer of electron from an atom that has too many like sodium to an atom that doesn't have enough like chlorine. Once this electron been transferred, both atoms become ion with full outer shell electron. The important bit here is that the two ions have opposite character that make them attract to each other by electrostatic force to form ionic compound. We call this ionic bond which is really strong. We call this drawing by dot and cross diagram. This is because we can tell which give and which get electron. Now, for our last session, that covalent bond take place when rather than taking or giving electron, atoms share their electron in order to fill their energy shell. Covalent bond usually come from two non-metal elements like two chlorine atoms. In this case, both of them need an extra electron to get a full outer shell, while they cannot give each other electron. Instead, they need to share an electron. They each share one of their electrons, so together two are being shared and they each get one extra. Display formula can be used if you want a simple drawing when you just write the chemical symbol of the atom and use the line to join the atom that are covalent bond together. This method is easy to draw a big molecule that will take too long or too complicated to draw, as dot and cross diagram. This method will not show the 3D molecule. This is the downside of this method. For this, we can use a 3D model which try to show how the atoms are actually arranged in real life. For the slightly harder example, we will use the covalent bonding of ammonia. It has the molecule formula of NH3, so we can tell that the 1 nitrogen and 3 hydrogen in our example. We will only draw the outer shell. Because this is hydrogen first energy level, it can only hold 2 electrons, so each hydrogen is going to need 1 extra electron to fill their shell. While this is nitrogen second shell that can hold 8 electrons, so we need 3 electrons to fill. So, if each hydrogen share 1 electron with the nitrogen, then all of the atom will have full outer shell and all done. If you want to use display formula, just erase the circle and draw the line between them. For the 3D model, it will become hard to draw because of hard to predict shape, but you don't have to know this. This example are called simple molecule. Substance which are small molecule in which the atom in the molecules are joined by strong covalent bond, but between the individual molecule there are only weak intermolecular force which is easily broken. Other simple molecular substance worth knowing are water, which is H2O, and methane, which CH4. Covalent bond can also be used to make much larger structure, such as polymer and giant covalent structure. Basically, polymer are long chain made of lot of repeating units, which we call monomer, and are all used to make things like plastic bag or t-shirt. Meanwhile, giant covalent structures are things like silicon dioxide, diamond, and graphite, which can involve billion or trillion of atoms arranged in regular lattice. And because all the atoms are joined by covalent bond, they are really strong. Anyway, that's all for now. Hope you enjoyed this video and thank you.